Good.
All right.
Okay. And whenever my second online speaker arrives, I try to make him a co-host. So that's probably something to remember.
Yes. So Kathy is already a co. Oh,
Yes.
she's already
Yeah.
a co-host. Yes.
Yeah, that should be good. She's the last presenter.
All right.
And then we have one virtually just before.
All right.
Okay.
Jätterolig bakgrundspresentation.
Yes, they are all in the presentations here and then so they will be that's basically so I have them all. You can see I guess we should get ready. Okay. All right, don't be shy. There are still plenty of spaces, even in the front row. All right, we are about to start. And we have a fairly busy schedule, 5 presentations, 90 minutes. So if you have a number of questions, be quick when there's a time to ask. I think we might not have time for a number of questions. And I hope I'm able to sort of hook up you in the room and a number of people somewhere around the world. If not, and you become aware of that, let me know. My name is Tuomas Alaterä. I come from the Finnish Social Science Data Archive, and I'm also the communications chair of IASSIST. Fortunately, I have very little to do with conference-related communications, but do feel free to let me know if you have any communications-related issues. Well, that's enough of me. Let's not spend our valuable time there anymore. First session today in this session C1, Data Services for the Future, is called Towards Understanding the Ecosystem of Sustainable Data Culture. We have two presenters here. Emma-Lisa Hansson, who works as a project with projects relating to research data architecture at Lunark Center for Scientific and Technical Computing at Lund University, Sweden. Her work involves national and European projects, and she's also an activity lead in Buerli 2 project, which I believe is to do with supercomputing. Is that right? Good. And then we have Mattias Persson, an open science coordinator at Örebro University, and has a PhD in economics. He has previously worked as a research coordinator for social sciences at the Swedish National Data Service. And as an open science coordinator, his focus is on data accessibility, fair data management, long-term storage, and supporting researchers in this area. So the floor is yours.
Thanks a lot, and I hope that this will work now. As a, there's the Zoom meeting and share screen. So we are going to talk about today towards understanding the ecosystem of sustainable data culture. This is a joint venture between me, Emma-Lisa, and people at Chalmers University, and our colleague Tuomas, that is not, it's in the room, about how could we help researcher giving the proper service over time. Okay. We have some different challenges here in Sweden due to often our universities, broader university, combining a lot of different science fields, and that we need to find a long-term sustainable in a fast-paced and unpredictable area. We don't know what's happening in 1 or 2 years with all the data challenges and development we have. And with that, we have to develop all these areas as well in the same time, but we couldn't begin from the start because we have researchers that need support in the later stages as well. And that we need to think about the compliance and data sovereignty that we have in these fields. And as well, it's not just in a local department, it has to also focus on to the global research community. And we have a lot of actors in this landscape and no coordination in some sense. And we have thought about this. We have a group that is focusing on enterprise architecture in the Swedish National Data Service Network. And we that is one of the things we have discussed. How can we help the researchers in a good way? And we have a project that started at Lund University and then have developed, and now we have both taken Chalmers University, that is a technical university, into this, and then we have Örebro University, that is a broader in comparison, smaller than Lund and so on. And what are the capabilities we need to make high quality research data? How is the current state, and what do we want in the future? And as you see here is the capability that it's a cohesive, limited, and independent component of the business and in the business architecture. And we have it as a we see this from the view of the researcher, but we take in the support function as well, as this is the wheel that we have developed together in the group firstly, then it's all the researcher gave us thumbs up because it was easy to follow the model and give their input and so on. And it was a common ground to work from, and they understood where we're coming from. And it helps the researcher, not the support function, to tell us what they need in the different parts. It's not our view on what we want to support them on. And as I mentioned, the first version was mapped out in our project team and then tested on in Lund, for example, and then we made some corrections, and then we used it in both at Chalmers University and Örebro University. And the method we used was going through the nomenclatures, so we talk about the same thing, even if we don't use the same words in the fields, because a cat is a cat, but we can have it as a Bengal cat or a tiger. So we use the same wording and we understand each other. And then we have a survey that has been previously conducted or conducted during the project, so we can get information of what they have for issues. And then we conducted interviews, both individuals with researchers from different disciplines, high computing areas, to qualitative researchers. So I know what Brian in the previous presentation talked about, all the issues with sharing data there. And then we have also group interviews as well, and going through all the compliance lists we have as a research data in Sweden, for example, and on an international part. From these interviews, we created maps. How is it working today, and what is the issues, and what should we build upon? And then we have the capabilities described from this current to the ideal states, what are needed. And then we have also created user stories. And we have to find alignment necessary between all these fields here. For example, policies, resources, practices, processes, stakeholders, and infrastructure and architecture, and make it possible for a researcher to work on different universities in a good fashion. And that was one of the issues. Collaboration between universities was one of the issues they was giving us. But then we also have to talk about, we just focus on the infrastructure that was focusing on research data. So before each interview, we show them this, that we are talking about 4 levels of infrastructure for research data, from the fundamental IT infrastructure to those parts where we create data as high computing or survey tools and those types of infrastructures, to the research data management, and then the research data service that could be research data catalogs or the supporting stuff, or that was that. With our support from the university or the community, how can we do? So this was the focus we have. So we often try to tell them, this is not the question you're supposed to give the answer to. So focus on the research data. And when we have the first map, we found some thematic structures in the research journey. It's the cost of collecting data or using high computing service, storage, how we share and how we collaborate with others, and as well, how we publish data. That is, some of the researchers know where they should publish data and how to go further down the road with all the stuff. And as you see in this picture, there is small balls. Emily is going to talk about this, but this is illustrating where all the researchers have their good responses to the question. They have a lot of good responses and or bad experience in the beginning, and then they have a little bit less to say when it comes to making data available, archiving, and reporting about research data to the funders. So, Emily.
Okay. So this is a map of the level of satisfaction based on the interviews. As you can see, in the beginning of the journey, the researchers were very satisfied, basically between the methods that they were using and so on. And as they progress in their journey, the satisfaction actually becomes less. So these are some statements also from the researchers that we have highlighted. The good ones are the green ones, the lesser ones are then the yellow ones, and then the red ones are the ones that they think should be something we should be doing something with. So the green ones, well, they have freedom and research methods in the research structure. They have agreements and contracts with the industry that is very clear for them. They get services by data managers, something also that they're very satisfied with during their journey. And then they become less satisfied with the allocations for high performance computing. Maybe also high performance computing services are not working for them. No support are given during their data management process. They need more computing power. There is no harmonization between different kinds of data management and infrastructures. Commercial value and patents are difficult. Juridical questions are unanswered. Management directives are just strange for them sometimes. And data management takes too much time from their research. And collaborative spaces are also missing from them. The red ones are then Linux integration is missing in the departments. There are cooperative problems between universities and hospitals with the data. The transport of physical hard drives are, well, bothersome for them. They have to bring hard drives everywhere with them, and they can't upload their data easily. There are, as I said, question goes unanswered. Quality of data is something that the researcher thinks is forgotten. FAIR is not talking widely, they think, in the research community. They experience that there is no structure for them to archive their research data. They lack research data support and also clarity on what is actually data. We also wanted to examine if the research support is given when the support is actually needed. So this is something that we investigated between the research supports and also between the researchers. So the orange ones are the ones that we have marked that this support is lacking. And the green ones are the things that the researchers are doing. We have a description of all of these icons also. And these small like balls, they are the frequency of the icons. We also discussed with the support organization how they are talking to each other. Is the communication single communication or is it double communication? Do they get answers back between them? And the green ones indicate that these are communication that goes between the organization departments, and the blue ones are a single communication. They don't get anything back from that organization or department. And these small maps over here, this is a timeline that were given to a university. And the highlighted areas, they are yellow and red. So this is heat maps indicating that something has to be done. And through the different years, then we gave recommendations on what has to be done. It's between development and organization, and different arrows that marks the time on when it has to be done. This is a description of the capabilities that we talked about. So this is the current situation. This is making it available, protecting data in this section. We described for the university what is the current situation that they have right now regarding protecting data. And this is the future situation, the situation where we actually want to go towards. So where are we actually heading and what is possible to do within a time frame? The people behind this work is me, Mattias, of course, Olof Olsson, I'm not sure if you're here, Tuomas Kieselbach, and also Monica Lassi, that is now working for IKEA. With us in the project, we also engaged a researcher also, so that we didn't forget the communication with the researcher also. There is a link to Zenodo for the reports. This presentation is also uploaded. Let's see. Yeah, that was the end.
We are on time, so now it would be time to take a question or two. Over there. And then I need to test, does this one work as well, right? Yes.
Yeah. Hi, I'm wondering if you arrived at any recommendations to the universities and other organizations providing researcher support?
Yeah.
for the reports.
Yeah, how the mother organizations or organizations catering to the researchers should what they should do to meet the researchers' needs.
Yes, we did this on a local level, but also on a national level. Also, we had a report that was guided towards storage, actually. So that report was for a national level, but we also did this on a local level. Of course, the recommendations were different because recommendations are a bit different for a national level than for a local level, of course. And you can read more also about this in the report. Also, there are lots of recommendations done, and also for all of these capabilities are explained in a separate document, also outlining the present mode and also the future that was recommended for that local university. I'm not sure if you have anything to add, Mattias.
No, it's a good way to just get a current picture, and it's we have seen others wanting to do this as well in other universities. And
it seems there's one question in chat. You probably can read it.
Yeah.
Reports available in English.
Is it only in Swedish?
Yeah, the reports are only in Swedish. However, Germany has translated them somehow I'm not sure if, but they didn't use Google Translate, they used something else. So it is possible to translate them if you want to, but they are in Swedish.
Okay, do I see any other questions right now? I do not, so thank you for your presentation, and we will move on to the next one. So that I'm able to present you better, I'll grab my notes. Okay, let's do one more thing. Yes. Okay, the second presentation in this session, visions for the European Social Survey multi-level application. We have two presentations here as well. Hilde Orten is a sociologist working as a metadata specialist at SNIC, Norwegian Agency for Shared Services in Education and Research. Her focus of interest is in cross-domain interoperability and fair implementation. Hilde currently serves as a vice chair of the DDI Alliance Scientific Board. And then we have Anna Thorne Pettersen, who is a political scientist working at SIC. And she works with European Social Survey and the ESS multi-level application. And the floor is yours.
Thank you very much. Let's see how we do this. So sure. Thank you very much for coming and listening to us. We will talk about visions for the European Social Survey multi-level application. And that is an application that has been developed at the former NSD. Our institution was called that earlier. Now we were merged into a state-owned company called SIC, as Tuomas just described. And this is a tool with the aim to integrate survey data from the European Social Survey with contextual data of different types. And this upgrade and the related project is funded under the IASSIST Future program. And we'll now look a little into what that is. That is basically the framing for the project. And the IASSIST Future is a project under Horizon 2020 with the aim of implementing the European Open Science Cloud, IASSIST. And the aim of IASSIST is to give European researchers access to a wide range of fair data and to make them available from the IASSIST portal. We will not talk so much about the IASSIST portal here, but more about the tool through which we will make our service available. And then a little more down from the IASSIST Future, we have Work Package 6. And what is that? Work Package 6 is led by...
It seems that the virtual end doesn't see the slides changing at all.
Okay.
Do they change here? So we are broadcasting this screen, I believe. Right, this is when I want my technical lead to lead. Why is it doing that? The solution is approaching.
Maybe. It's not sharing the screen.
Yeah, but we are. They are not.
They're not seeing this.
Yeah, I mean, they are not seeing the presentation mode, but the screens are not.
Vad sa du att?
De ser bara programmet, de ser den.
Men vad är det de inte ser?
Stopp, alltså de ser inte.
Okay.
Så att starta share screen.
This can happen.
Så det.
Är det där?
Ja.
Okay.
I think we were only talking the title slide before that happened.
Right. So he fixed it.
Doesn't matter so much.
Yes, so we've just promoted Mattias to be the technical.
Okay, thank you very much. So, okay, the Work Package 6 of IASSIST Future. It's led by Christos Avanisidis, and he's from Panosk. And the IASSIST Future Work Package 6 is really a space where science clusters and infrastructures can join forces. We have different approaches, different languages we speak, and different culture. And but when working together, there's a huge potential to kind of find solutions together and the trading zones. And that's what we try to profit on in this project. As you see here, some of the clusters the clusters involved are mentioned, and you see the Skjåk, Escape, the Henry, that we will be working with, and many others here. So Yeah. And what is the objectives of work package 6.3 or science project 9, as it is called? And that is our project here. It is to demonstrate that relevant environmental data and data on citizens' values, attitudes, beliefs, and involvement can be combined for political, social, and scientific analysis. And also a kind of key indicator for success is to make those data available from the EOSC Future platform. But that will be the last step in our work here. What are the expected users of our new application? First of all, we are thinking of social scientists. After, maybe sometimes policymakers could be interested, and then also researchers from other domains like environmental scientists. But this is a little new, so we will see what comes out of it. And then I leave to Hannah to talk a little about the application as it has been, because she has been working on that service.
I have been working on the IASSIST multi-level application as it has been. The application was launched in 2012, making it possible to download regional level data on demography, economy, etc., together with the data from IASSIST. So this tool makes it possible for users to subset and customize their datasets to their needs. However, the funding from the EOSC Future Work Package 6.3 Science Project 9 opens up new possibilities for this tool. We are currently working on upgrading the application with the aim to support integration of data from different domains for cross-domain analysis. So we have the survey data from the ESS. We also have the regional contextual data collected from different sources like Eurostat, World Bank, the UN, and others that are already supported by the tool. And the new addition to this application will be air quality data and climate data. And Hilde will speak more about these sources.
Thank you very much, Hannah. And then again, so what is the background for this idea? Well, back in 2016, the European Social Survey fielded a questionnaire module about climate change and energy use, and wanted to capture the respondents' attitudes to central concepts like climate change concerns and climate change beliefs. And then some research questions arose from that, like, do observable indicators related to climate change and local air pollution have effect on climate change concerns and beliefs? And local air pollution data could, when combined with other data from the ESS, also be used to explore effects on people's well-being. And when starting to working with this, we were thinking what could really be our environmental indicators. And on the high level, we were thinking of two things, like indicators related to climate change. That could be typically things like temperature, precipitation, wind strength, and perhaps draft indices. And for air quality, it is the classical indicators for that is inhalable particulate matter, nitrogen dioxide, sulfur dioxide, and ground level ozone. And what will be our kind of target variables, or what is the thinking behind that? And there we got very good help from S&D here and the expert David Reiner, really, and also Iris and Ilse from S&D, to figure out that it could be good to think about anomalies like heat episode days, extreme precipitation days, storm, extreme wind, and things like that. And regarding air quality, we are thinking of worst index air quality level values across the pollutants, like on the day of the interview, it could be before, like 2 days a week, and things like that. And then we have region and time, because all these measurements, both the IASSIST interviews and also the measurements, they are for certain areas and at a specific time. And as it is environmental indicators, we were thinking it would be good to focus on the larger cities in Europe, and there should be enough ESS respondents that analysis would really make sense. So there we ended up with to consider cities like Stockholm, Berlin, Prague, Budapest, Vienna, Madrid, Paris, Brussels, London, and Oslo. And the areas will be defined as NUTS polygons on different levels, depending on the amount of ESS respondents in each area. And the measurements, environmental measurements, will be defined by station, location, point, or grid. And regarding time, we will be able to get time on the hour, but our unit to be used will be the day. We found that would make sense to be the day. And the time period, of course, from 2016, when the module was done in the ESS, and onward up to now. And then later, maybe the ESS will field other questionnaire modules with the same topic. And then we have reference data for comparison, and that will be typically a 30-year period, like the meteorologists use. They always use a 30-year period, and we will use the latest one, the same as they use. And then we have started to look into possible data sources, and the one we explored mostly so far is from the European Environmental Agency about air quality data. And we will also look into reanalysis data about meteorology and also air quality to compare about those we already explored, and also from maybe from SPY regarding dry spells. And eventually the ENVI hub will also be able to provide data, but that isn't finished yet. But maybe in time, relevant data for us can be harvested from them. And ERA5 and CAMS, they are reanalysis data. So they are model-based, based on satellite data and controlled against in-situ stations data. And then plant functionality for the tool. We are now on the stage of doing the functional specifications, and then in the autumn, our developers will start on this. And we think our data will be open. We will not republish the data we harvest from other sources. We will make computed indicators that we will make freely available. And users should be able to explore data like descriptive statistics and tabulation, graphics, box plot, and so on. They should be able to download user-defined data to select variables in time and location, and should be able to have rich metadata and high level of granularity. And the new DDI cross-domain integration, DDI-CDI, is planned to be used to bridge between the data from the different domains that have different structures. And we will also provide provenance, standardized provenance information to be able to describe what we do with the data from we harvest them till the end product. And we would like to make that available in a standardized form. Our goal is to be able to harvest data from the different sources using APIs, and also allow harvesting from this tool. And this slide is just a sum up about what we have been talking about today. We have the ESS data about individuals, their values and attitudes, behaviors, etc. in time and space. And we have the existing regional data that is more about population statistics, like Hanna was mentioning. And we want to add these new environmental data, maybe in time also biomedical data. We'll see, but for now it is these environmental data also in time and space. And we will use DDI, CDI as a lingua franca to kind of bridge between those. And then we seek to achieve machine operable harvesting and transformation and to document provenance. And in the end, we hope to have a fair multi-level data application with open data. And then partners and contributors. As you see here, there are two clusters involved, Skjåk and the ENRI consortium. We also had some help from some external contributors in Norway. ESS Eric is involved within Skjåk. And from SESTA Eric, we have SND involved with Iris Alfredsson, Ilse Leis, David Weiner. And we also have two metadata specialists with us as consultants. That is Joachim Vakarov and Arifan Gregory. And yeah, any questions if we have time?
Yes. Yep, there is time. So put your hands up there.
Steve, oh yeah, okay.
I'll take the left first.
Thank you very much. The question I had was around the privacy to the data subjects that are in this platform. So typically, if we're thinking of like environmental data, like air quality readings, they would be fairly geographically specific readings. And normally when it's open data, you don't provide that much geographic information to reduce the risk of identifying someone. So I just wondered how you're balancing that risk in order to make the data available openly.
You mean, if I heard you correctly and understood you correctly, you mean the location of the person, right?
Yes.
Our problem and our advantage is that we are not allowed to identify the exact location of the residents of the respondents. So in time we are very good because we can be exact on the timing of the interview and combine in this respect. Regarding the area, we need to go by NUTS level. And for climate data, it shouldn't mean so much. We will see how it will work out regarding the air quality things.
Okay, thank you.
Mm-hmm.
And then we give Steve his chance.
So I've got a little bit of background. I know a little bit about the project. It'd be useful probably just to say a little bit about why CDI. So CDI is the next version of the DDI standard. Why does CDI matter in the context of this particular project? Why not one of the earlier versions?
Well, there are several reasons for that. The CDI is kind of modeled to be more generic than the other versions of DDI. They are more kind of domain specific, and it also has some things that are really good that we could use immediately, and that is what we call variable role, or that you can assign specific roles to variables in different structures, right? So for instance, you have these measurement stations, and EEA have information about them, and that can be useful to include in our data. But they call that metadata. But for us, it would be very nice to have it, but to kind of tag it as not tag it, but structure is as an attribute in this context, because it applies to, it is not analysis data. The data for analysis are the survey data and the measures, right? And then you can also, by this, you can indicate not on the level of the variable, but on the level of the structure you have. You can indicate what is what in this context. And then if, for instance, you have data in a specific structure and you transform this structure to something else that you can also document in the DDI, CDI, and then the same variable doesn't need to have the same role in a new structure. So this is a very useful feature. Then you have to document changes over time. You have the variable cascade, and that is also very useful. That exists in DDI lifecycle already, and maybe we can, and the ESS data are already structured in the variable cascade, so that we can probably go easily from life cycle to DDI, CDI regarding the variable cascade, which is also a big advantage. Also, DDI has something that is very specific that we may or may not implement in this project. We are a little early to say that, but they have something that you can really follow each observation or computed variable. We call it datum, but that is not only the value you see, but it is also combined with the conceptual value that explains what it is. And this, then you have lots of information attached to that, so you could basically follow each of the datums when they travel from different structures and domains. So that is also a very useful feature, but we'll see how far we get with that. But that are some, and also that you are able to cover not only rectangular files, but you can, if needed, you can cover key value data. You can cover long formats and so on. So and also it is in a language that is more generic, also not so domain specific, and it's model based also. So, and you can, what's very nice that it is kind of a little modularity in its structure. So you could basically take out, for example, to use a set of components. You don't need to take everything, but you can take out what you need and yeah, really use it. And also that it to align with life cycle, that's important, so that you don't need to do everything over again, but you can reuse some of the things that already exist, could also be very useful.
Thank you. Let's thank Hanna and Hilde once again, and then we'll move on. See how we go about, because your presentation is in it's a PDF, all right? Yes, it's there. Oh, we are still sharing the other one. Okay, technical lead. Why I'm not seeing the controls? They are there, but I can't access them. What did you do?
No, I didn't do anything.
Well, it definitely adds a new sort of a component into your session when you deal with two different audiences and technology in between. Right, so now we can stop sharing. Great. Where was it's there? So, yep, it's visible. Thank you so much. And I'll try to do the bit I'm able to do, which is introducing the next speaker. Presentation number 3, Data SWISSUbase, a national data archiving platform tailored for scientific disciplines. Presentation by two co-authors, Stefan Buerli and Bojana Tasic from FORCE, Swiss Center for Expertise in Social Sciences, and Bojana will be giving the presentation. She's a development and infrastructure head at FORCE, and also a technical lead for the mentioned SWISSUbase project. And she has 17 years of experience in commercial full software lifecycle and over 10 years of experience in agile software development. And generally practical IT matters which relate to social science research. She has been involved in many projects aiming to build European research infrastructures, and has been an active member in CESNA technical working group as well. So welcome, and the floor is yours.
Thank you. Just to do the full screen. Hello, everybody. You cannot really see the title fully, but it's fine. Well, I will start the talk with challenges as the same as my colleagues from Sweden and during the first presentation of this session. I think it's very important that here at this conference, we don't just present our achievements and what we are doing well, but also to discuss the challenges that we are all facing and to exchange actually how different institutions are overcoming challenges. So for sure you will agree, because mainly of you are coming from the social science data archives. Currently, the main challenge is to get the data in proper quality, but really to bring data into the system. We have different ways of doing this. There are different tools. Some tools are in the development process. There are some well-established tools and so on. But this is the main, I would say, challenge today. But if we step even forward, and if we imagine in the future, like 10, 15 years from now, we have the data. So this way or the other way, all the challenges that we are facing today are actually solved. So the data are in some systems. So imagine if every year, it depends on how big is your country or how large is your service, how many data each year would come in next 10 to 15 years. So what would be the future challenges that we will face 10 to 15 years from now? We at FORCE in Switzerland, we believe the main two challenges would be discoverability. So when I say discoverability, I don't think findability, because if there is a DOI and you know what you're searching for, you can find this with the DOI. But it's just to discover what is out there. So imagine like 15 years from now, they can be hundreds of thousands or thousands of data in some systems. How you would really discover as a researcher, to be inspired with the research, to be aware of the research that is done if there is such a big volume of the data inside of these repositories. On the other side, we also believe that reusability would be one of the biggest challenges. So the quality of the data that is inside of these repositories, what is the level of the quality and how this data could be really reused. We also heard this morning that also methodologies are changing. So if you well describe the methodology that was used like 20 years ago, will the future researchers be able to understand this old methodology and actually to understand the data and to use the data? So with SWISSUbase, we are addressing these challenges in two ways. So we believe that rich metadata is something that is very, very important. And when we say rich metadata, we think about discipline-specific rich metadata, so that really the data are the fine-grained levels in details described, so in the order to, in the future, you could discover them. We believe in the future, we would have maybe artificial intelligence on a higher level, but in order to have the system to work, you need to feed them with information. Also, knowledge graph probably would be used and so on. But in order to feed them and to have this actually possibility to discover rich metadata are very important. On the other side, we believe that services and expertise behind the services it's a key point in order to have the high quality of the data so they could be really reusable. So here we have services, and for sure we have humans behind at this point in time. In the future, maybe it will be combination, but for sure we will always have people behind, and people have the nature that they would like to be as researchers, probably and most likely they would prefer to be guided by people during the process, and not just like with some system that would suggest some things and so on. So what is the SWISSUbase? SWISSUbase is the project we started in 2019 together with the University of Lausanne, University of Zurich, and FORCE, Social Science Data Archive. At that point in time, University of Zurich needed a solution for the linguistics research. So they didn't have their own solution. We at FORCE, we have already a data archive for 25 years for social sciences. And we said, okay, and University of Lausanne, they need like a general archiving solution for all their disciplines. And we said, okay, let's combine all this knowledge and let's try to reuse our platform and make it more modular and extend it so it could fit the needs to different research disciplines. Currently, we are like a legal partnership between the three institutions, and we are association around of SWISSUbase. So what is SWISSUbase? SWISSUbase, it's a platform and a service. We strongly believe platform on its own, it's not enough. We really need a service that supports this platform with people with knowledge around the platform, but also about the best practices who are actually supporting the researchers. So it's an archiving long-term preservation solution for data collection, preservation, and dissemination, and it's fitted to the research discipline-specific needs. On the other side, we have service. So at FORCE, we have the archive for more than 25 years, as I mentioned. And what we do, we support our partner institutions. So each new partner that comes, we support them to establish the service to serve their own community. What we are not, and I think this is important also to say because people are mixing us with other solutions. So we are not, as we would like to say, deposit and forget data repository. So we are not repository where you would just put your data, get DOI, and forget about them. We are not virtual in research environment. So we really come at the end of the data life cycle. And we are not living archive. So the data are not changed with versioning if there are some new changes, but the data are not live in that sense. What is behind it, as I already mentioned, it's like an institutional framework. So we have like a backbone where SWISSUbase as the platform. And then each partner institution has its own, we call it DSU, which means Data Service Unit. They are establishing their service. They are using platform SWISSUbase, and we build like a network of the data service units. Currently, we have three. Soon we will have the fourth one, which will be humanities. They will join in Orten. So we support all the partner institutions to set up their DSU, to set up their service, and then their DSU is responsible for data curation, quality assurance, and frontline support to their researchers. Researchers and communities are on the top. So each service is responsible for their community. So to come back to the main points, rich metadata and services and expertise. So how we build SWISSUbase, we really tried from our old system that is social science specific to take out actually what are the common things for all research discipline, what are like the core metadata that are the same for all, and take out the part that is really discipline specific. Also, the whole process of the archiving, it's the same for all research discipline. What is different, it's really like the data, the volume of the data, and metadata that are describing. So we have this pluggable part that is discipline specific, and the core that is the same for all research disciplines. Regarding the metadata standards, we strongly believe it's very important for all the interoperability and to understand the data. So we have so-called general schema, which is the same for all research disciplines. It's data site compliant. And then we have social science schema, which is DDI compliant. So if the researcher chooses to create a social science data set and study, they will have DDI compliant metadata. For the linguistics, we have implemented MetaShare compliant, and they're also Clarin compliant. And currently we are developing, so for humanities, we already developed the metadata profile. We have to do technical integration. Technical integration normally It's a matter of weeks, 1 to 2, depends if they have some specific additional needs that would change the whole workflow and the process. We are also working with geosciences. We started to develop the process for the geosciences, the metadata part. So I can tell you the most difficult part at this point is really to define the metadata profiles for other research disciplines. I have to say that social sciences are quite advanced in comparisons to some other sciences and other research disciplines. Some they still don't have any standard, some they have some standards. So it's really diverse. And with SWISSUbase, if you use general schema, you could add just general metadata if there is still not your discipline implemented. And then later on, you just do upgrade, you would have additional metadata field that you have to fill in. On the other side, as I mentioned, we have services. And behind the services, we are building actually the specific guidelines. We are supporting the DSUs to develop their guidelines based on SWISSUbase guidelines. We're organizing trainings, helpline, and support policy. What we also plan to do is to build like a common helpline for all the DSUs where they could actually exchange, because what we found out so far is that some institutions are maybe more advanced in some specific areas, like for example, humanities, they're very advanced with visuals, how to preserve for long-term visuals or databases. So we really try to build community around services and to exchange, like we in social sciences, we're very advanced with like sensitive data, with ethical issues. So if some other DSU has a specific problem, they could come to us. So really to build this network among the services so that all the services, they provide the same and high level standards. I will not go into the details regarding the platform, but we are completely OS compliant. We have data producers, data curators, / data stewards, and data consumers. And this is the process. Data producer adds metadata and data inside of the system. They choose the license. We support different kind of licenses, open all 7cc licenses, plus the closed specific licenses depending on the sensitivity of the data. Then data curator takes over and does really the quality assurance of the metadata of the data. And they are also preparing submission information packages, archival, dissemination, and they're publishing in the catalog. What we plan in the future with SWISSUbase, and I'm sure that you're facing the same problems. So on one side, we have this rich metadata. So in other words, a lot of fields to fill in by the researchers. And then also we come at the end of the life cycle. And then researchers are by default not very motivated in general to do all this process. So what we really try to do is to actually link our services and our system with other systems and services that come before us. So during the data management plan, we would probably do, you will see on one of the next slides, we want to do integration with virtual research environments. So what comes before the archiving? On the other side, to expose more our catalog, we would do links with SESTA, Clarindaria, and EOSC in general. We would also focus more on the sensitive data because at the archive, we really have some highly sensitive data. So we're also discovering like what would be the options of remote access to high sensitive data. And we will also go more into the direction of building machine actionable data management plans. So I'm really looking forward to see the presentation on Friday afternoon from colleagues from Norway. They already built machine actionable data management plan tool. So really to follow the whole process. So basically when the researchers, they come to us, we can already take over a lot of metadata from other systems. And then at the end, they would just add in addition metadata for archival and dissemination purposes. Regarding the metadata schemas, in addition, we plan to develop. So as I mentioned, we currently have linguistic humanities. We are working on geosciences, and we will go towards health and medical sciences, which we find them similar. So we were just slowly growing. They also have issues about data sensitivity. Regarding service, further build policy, developing user guide, video tutorials, organizing trainings. We are organizing trainers, so we are training the DSUs, and they are doing trainings to the researchers. And at the end, promotion. Currently, we have 4 partners. The plan is to actually reach out. We already reach out to other universities. There is high interest of other universities as well. So to have new partners and further build community, organize workshops and webinars. Thank you. That's all from my side. Any questions?
Thank you. Time for one quick question, I would say, then we can imagine that we kind of finish on time. I didn't say you are not allowed to ask a question. I said you can ask one question. It's a totally different thing. There it is.
Hi, I'm Archana. I'm from SIC, previously known as NST. And my question is regarding the discipline-specific metadata schemes you are working on. Do you involve with the researchers, and what metadata standards are you looking at? And can I have a look at them, or where can I have access to them, basically? Thank you.
Yes, yes. So we are actually working entirely with the community. We work like with main actors for that research discipline in Switzerland, and then they are organized by themselves as a community. Normally, when they choose this, as I said, depending on the research discipline, some they already have a standard, so they have a look at the EU level, what is the standard, and then based on that, they build their own Swiss, I would say, metadata profile for that research community. I can tell you that the process is very long. So for the linguistic community, it took us 1 year to define the metadata. I mean, there was like days of discussion over like one field inside of the community. Do we need this? We don't need it. This is very long process. We are happy to share our metadata profiles. You will have my email there as well. We will be happy to share and exchange. We already did some exchange with our colleagues from Sweden. So I think if we do exchange on that level, we also are making sure that is international, if I can say like that. But the process is very, very slow. We also, so the first 3 years was funded partially by the Swiss universities, which is like an umbrella organization among all the universities, and partially by the partner institutions. And starting from this year, we are self-financed. So all the partner institutions are contributing to the further development of the solution and services. Thank you.
Thank you. And then we move on. All right, and then we move to the exciting virtual part of our session, and I just need to make next presenter co-host so that he will be able to actually share his screen. Go there. All right, so now 2 more presentations, and that looks quite good. It almost looks like it works. Joining from Canada, number 4 today in a presentation called Redesigning a Federated Data Discovery Service is Mark Goodwin, who works as a metadata coordinator at the University of British Columbia. He works closely with the Digital Research Alliance of Canada's Research Data Management team, and is responsible for Federated Research Data Repositories Discovery Service, and leads technical support for the DataCite Canada Consortium. Mark is passionate about improving access to information and excited to help and to enhance discoverability of research data in Canada. Mark, the virtual floor is yours, and we hope that we can hear you.
Hello.
Yes, we can hear you.
Me. Great. Awesome. Thanks so much for that introduction. And hello, Gothenburg. This is the first time I've done one of these kind of hybrid things, so it's pretty cool. I wish I could be there. I've always wanted to go to Gothenburg, but wasn't to be this time. but I'm very happy to be presenting virtually. So yes, I am Mark Goodwin, Metadata Coordinator based out of UBC, work with the Digital Research Alliance of Canada. I'd like to acknowledge that the university I work at is located on the unceded territory of the Musqueam, Tsleil-Waututh, Squamish, and Coast Salish peoples. Very grateful for the opportunity to work on their land. Yes, the title of my presentation is Redesigning a Federated Data Discovery Service. So we'll start by looking at the Federated Research Data Repository, or FRDR, a brief intro to that, and then specifically the FRDR Discovery Service, and then we'll move on to the FRDR Discovery Redesign Project, which is kind of what's in store for the future of the Discovery Service at FRDR. So what is FRDR? It's a scalable federated platform for digital research, data management, and discovery. It's provided by the Digital Research Alliance of Canada, which is a fairly new organization within the last few years, also known as the Alliance. There are three main components to FRDR. There's a national discovery layer that indexes research data from Canadian repositories. There is a repository itself with dedicated curation support and preservation functionality with an Archivematica integration. So for this presentation, we'll be focusing on the discovery service portion. So this is taking a bit of a closer look at how the discovery service works. On the left-hand side of this slide, represented by that kind of funnel diagram, that is representing the harvester that we use to power the discovery platform. So metadata from data sets in various repositories across Canada is harvested and then made available in a single point of search. That's represented by that little computer icon in the middle. And on the right side of this slide, that screenshot is the interface. So you can see the main kind of search bar in the middle. We currently have over 75,000 data sets in there from over 100 Canadian repositories. So it's not limited to any subject area or anything. It's kind of a generalist tool for all research data in Canada. There are currently two ways to search in the discovery service. There's actually two separate interfaces. There's a text-based search and a map-based search. So first, looking at the text-based search, it's kind of your typical keyword search. There supports English and French language. There's filters for refining your search results. If you click on a record, you'll get some basic descriptive metadata and also a link back to the original source repository. So we're driving traffic back there as well. As for the map-based search, so like I said, it's a separate interface. It's an adaptation of the open source project GeoDesy. It uses the open source software GeoBlacklight. That's for the interface. Search results are driven by an interactive map. And although it's a separate interface, it is tied into the same data indexing as the main FRDR discovery search. The difference is that it only contains data sets that are either geospatial in nature, so that contains some kind of geospatial file, like a shape file or something like that, or it's any data simply associated with a location. So if it has place name metadata or coordinates in the metadata, that would be used to map it onto the map. So it could be a survey of residents of Gothenburg that would show up on the map over with a bounding box over Gothenburg. So this is something that we feel sets this tool apart from more typical geospatial discovery tools, in that It's not really subject specific. It's more of a generalist tool because we are pulling that place name metadata as well. And likewise, it's also available in English and French. This is a look at the map search interface. So you can see here, you're looking at a search results page. This user has zoomed in roughly over North America on the map. And then the results that are being populated are all the data sets that are located within that area of the map. So there's just over 2,000 results there. And as you hover over the different, the individual results, you'll see the location that's associated with that data. So right now, result number 5 is being hovered over. So you can see the blue box, which is called a bounding box, pop up showing where that data is located. And then there's some other kind of more typical discovery functions here. You can enter a keyword within the map search, and then also filters and sorting and that kind of stuff. If you click through onto a record, you'll see, again, some typical like descriptive metadata and a link to the source repository. Also, if the data does include a geospatial file, you'll see this kind of cool geospatial preview right on the record page. So when we brought the map search on and we had these two separate interfaces, it was more about just integrating the map search. We were still kind of building it and developing it a little bit and testing it. So it was never really intended to be a long-term solution to have these two different interfaces. It's not really ideal for discovery. It can be kind of confusing for users to have to go back and forth between the two different ones. That is what brought about the Discovery Redesign project. So we started this project about a year ago, and the aim here is to integrate the map-based search with the main search existing as it is, to bring those together and create a more seamless discovery experience and kind of enhance overall search capabilities in the process. And we also decided early on that it was going to become its own platform now. So we're going to be separating from the repository and preservation functions that will stay on their own site. And now the discovery is going to have its own website. So basically, we have the existing further search and the map search, two separate interfaces, put them together, and then you get Lunaris. So we don't have too much in the way of prototypes to share yet. It's still pretty rough form, but we do have this fancy logo. So I hope you like it. I showed it at a conference last week, so I can't say you're the first ones to see it, but you are the second ones, so still pretty special. So looking at the project now, these were some of the goals we went into it with. Like I said, we want to integrate the two separate platforms. We want to improve on the search capabilities through mechanisms like advanced search and filtering, that kind of thing. We want to better leverage persistent identifiers and controlled vocabularies, including ORCID, ROAR, and FAST. And more of a general one here, but very important, responding to diverse community needs for discovery of Canadian research data. So we wanted to make sure this is a really community-driven project. We've been doing user surveys and user testing all along the way to inform the project. My last point here also speaks to this, just around how different individuals are involved with the project. So we have a core team that includes the development team that we work very closely with. And then we have an expert group, a working group, which is made up of experts from institutions across the country And this group has been really instrumental in shaping the design or the redesign of this service and giving it that kind of community-driven and incorporating best practices and ensuring all of that is happening. So looking now at activities that we've completed and that we're currently involved in, we in the past year have completed an environmental scan and some initial user research. I mentioned a survey we did of our Canadian research data management community. We confirmed high-level website structure. So I mentioned that the Discovery service is now going to be its own website. We created and user tested a semi-functional mock-up using the Figma tool. We worked with design firms to establish our logo and branding and a wireframe design, kind of the look and feel we're going to be using. And as I mentioned, we worked with that working group to discuss and analyze all the different design components and how we wanted it to look and function. So we've moved past all that, and now we are working with the development team to develop a prototype. This is a look at all the open source software components that we're reusing to build Lunaris. So I mentioned the further harvester. Globus search provides text and geospatial search and filtering. Geodesy is metadata and data retrieval and processing. GDAL is a geospatial file processing tool. GeoServer is a server for publishing and distributing geospatial data, and GeoBlacklight is the interface itself. So there's a lot of different open source software components that are going into this. I'll now just run through a few feature enhancement features that we have planned for the redesign. And again, these are still kind of from images from fairly rough mock-ups and prototypes, but it still kind of gives a feel for some of the things that we're planning to introduce. So the first one I have here is searching by place name. So this would be packaged with the map search. So in addition to browsing the map, users can enter a place name and then zoom to that place on the map. So for example, if you know the name of a place, but you don't know exactly where it is, this would be a useful feature. Some other feedback we got was users would come to the map and not really know what to expect when they see it. So something we are introducing is this kind of clustering that previews dataset locations and the density loosely of where the data is located. And a few other things here, the ability to preview multiple geospatial files on a single dataset record page. So right now, if there's multiple geospatial files in one dataset, we're splitting them up into different records to preview all the different files, which is kind of confusing. It's another thing we wanted to improve with a redesign. We're exploring different ways to leverage linked data, for example, linking to related publications and other repositories, various metadata exports, and more. So next steps for us, we are continuing to develop the alpha prototype. We're going to be testing that prototype once we have it kind of in a functional, we have it functional and working. We will continue to work with the working group and consult with them. Promotion, which is what I'm doing right now. And big milestone for us, a release of the beta version. So that is planned for early 2023. So keep your eyes peeled for that. This is a list of all the wonderful and very smart people that have contributed to the project. Huge thanks goes out to them. And with that, I'll say thank you for listening. If you have any questions, I'm happy to answer them now, or you can reach out to me via email. Very happy to speak over email as well. So thank you very much.
And we always make room for that one question, even if that means that we're going to run a bit over, but I hope it doesn't worry you so much. Is there one question somewhere in the room or chat? Or you all wanted to save some time for our final presenter? Well, so be it. Thank you, Mark. And do pay attention to the possible questions in our platform. I need two mics. I can speak with use one, not that special. Okay, so last presentation in the session, digital transformation by design at Harvard Business School, is Katie McNeill, who's just appeared online there, and I probably can make that. All right. I'm not quite sure where we see Mark there, and instead of Katie at the moment, we do see Katie's slides though.
Can you hear me, I assume?
Yes, we can hear you. So if you could just reshare your screen, we'll see how that goes. Much better now. Right, Katie McNeill, who just appeared on our screen, is the research data program manager at Business School at Harvard University. There she leads its cross-departmental research data program with staff providing services across research data lifecycle. Previously, she has served as Associate Director for Access at the UK Data Archive and in data services at the MIT Libraries. Soon, Katie will be transitioning to a new role at the Federation of American Societies for Experimental Biology as a Program Director, a new initiative to advance data sharing and reuse. She has previously served as an IASSIST member in the Administrative Committee and in various working groups. And she is a member of Board of Directors of ORCID and co-chair of the RDA Working Group on Data Granularity. So here it's your chance to impress us, Katie.
Thank you. Well, and what's sort of fun about going at the end is that I can sort of listen to all the other presentations and make notes about the connections. So, you know, as you're listening to my presentation, you'll hear similarities with the Swedish presenters about sort of looking across services for researchers, with IASSIST trying to link infrastructure, with our Swiss colleagues around sort of how to have a both platform and services throughout the research life cycle, and with our last presenter around sort of federated discovery. So it's really lovely to be in a presentation with several similar groups. So again, I am at Harvard University, and we have various different schools focused on different research and teaching areas. So I'm in the business school, in the library, so I put us in the center. And other key players that you'll hear me talk about are the Dean's Office, who sets strategy for the school, Research Computing Services, which not only maintains technology infrastructure, but an important service layer for data science and high performance computing, the IT department, which provides sort of a fundamental IT layer, and then a lot of colleagues in research administration. And at the business school in the library, I manage, as Tuomas said, the research data program, which is a matrix program across different departments that provides various different services across the various different phases of the life cycle. So that's the role that I have in thinking about how our program connects with all of those other stakeholders in the diagram. So digital transformation, what do I mean by it and why? So for many organizations, the COVID-19 pandemic served as a catalyst for rethinking how work, including academic research, could be done in more efficient and innovative ways through the use of digital technology in ways that hadn't been done before. And so the Harvard Business School launched an initiative to think really strategically about this and to think about it along a scale of digitization, making something that's analog in a digital format, but without a lot of transformation, up the scale to new systems that can really not just tweak the way we work, but really transform investment. And I will be relatively brief because I know we're a bit running ahead on time. So the school launched a task force that consisted of staff and faculty representing departments and units from across the school that sought to understand how digitalization and digital transformation could enhance the value of what the school offers and create new opportunities. And they focused on 6 tracks and key questions in those areas. So what is our key strategy to work on? If we were to develop new platforms, what are the core building blocks in technology, process, and skills we need around that? How can we use digital transformation to enhance teaching and learning, connect with our network of stakeholders and alumni, be leveraged to sort of further communicate and disseminate information about our research? And what I will be focusing on is how can the research process itself be enhanced through digital transformation? And something that's underlying all of these that I know one of my fellow presenters mentioned before are our capabilities. What are various different, both sort of technical and staffing capabilities we need to accomplish this? So I'm going to focus on this research track. And as part of the project, the task force did a number of interviews with faculty and other researchers and found some key top needs. That faculty need more robust digital infrastructure, including more advanced data science and cloud computing capabilities, better information and better organized information to help them find services and resources for research across that sort of complex set of departments that I had mentioned before, and to be able to tap in and connect to people within the school, the university, and broader to foster research partnerships, to be able to better the business school researches organizations as subjects of research. And so to be able to think of new ways to make connections with those organizations, to be able to look at options for topics to research. And then the school in general is looking to find better ways to measure and maximize the impact of research and the school's research investment, because fortunately, the school has a program by which it is able to fund its own researchers. So rather than going to, say, a national research funder, the school itself plays the role of a research funder. So thinking about how to maximize the return on that investment. And so recommendations that came out of that are a more robust and organized research infrastructure, including a new cloud computing platform that, beyond just taking the files and moving them from the hard drive to the cloud, is enabling a greater level of self-service and advanced computing than could happen before. A redesigned and expanded research information system. Currently, our research information system, which tracks research outputs, is a homegrown system. A research services hub, which is able to provide a centralized view of research services across many different departments. A lot of faculty members don't necessarily know which department provides which services. And even if we were to build awareness on that, should they have to know, or can they just come to a centralized place and say, I'm at this phase of the data lifecycle, this is the service that I need, and then be pushed to the service provider? To be able to further leverage data science, both in conducting research and also in being able to customize research services for faculty potentially. So there's a high value in being able to provide personalized service to faculty. And at the moment, we do that in a relatively manual way, where an individual person will do a fair amount of work before, say, meeting with a faculty member to present them custom information from their research, but that can only scale so far. So can we use other kinds of tools to scale that better? To facilitate more research partnerships and expand infrastructure to support rapid creation of digital content in both research and in teaching. So what's come out of that, those processes and those recommendations, are specific sets of projects, some from the top down and some from the bottom up. And the main partners looking at implementing this are the ones that I had mentioned earlier. So again, we're moving forward with this cloud computing infrastructure, which is led by our research computing department. And they're really bringing in colleagues from IT and from us in the library to understand how the researchers use that environment and how that connects with the other phases and parts of the research that they do. And then we are developing this research services hub, which is going to be at the moment, a relatively static centralized website that lists various different resources for research, but you can go to one place to find out about it. But then there's this idea of bottom-up projects. And as we began to think about how to respond to the recommendations in the report, I felt like almost every meeting that I went in, I thought, oh, this relates to digital transformation. And I see this weakness in the organization that could be solved by doing things in a more scalable, systematic, less ad hoc way. And so there are several different things that our department and I have been working on trying to advance, saying, well, these are ideas that we have and they meet the overall organizational goals. So one is library management of faculty acquired secondary data. And what that means is we have a service, the library has its own subscriptions and we buy data. And separately, faculty members will say, create a custom agreement with an outside firm to be able to acquire data for their research that they may pay for on their own or it's limited access. We facilitate that process, except for the last mile that we don't actually take custody of the data sets. We arrange the licensing, but then the data goes to the faculty member, and we have facilities to try to, educate other faculty that, faculty member X has that data set, but it's a relatively manual last mile of access. And so we've been gaining support in the idea of the library using its expertise in managing information, not just to manage the content it has acquired, but to manage the content faculty have acquired for more robust management, metadata, and access. We also have seen the need, and this is an idea that was originally from a colleague of mine in the research computing department, of the need for a system to be able to track faculty research projects. The idea is that it would be an interoperable metadata system where right now, where faculty would be able to present and store information about their research projects, metadata about the projects, in one place that could be used and leveraged in multiple different research administrative systems. Because currently, if I was a faculty member, there are probably several different places I have to describe my project. When I'm applying for research computing space, when I'm filling out a human subject certification process. So the idea is that if we could have more interoperable metadata, we could save faculty members time because they wouldn't have to be hand entering things. And that seemed like a ripe opportunity for digital transformation. And also be able to have a better view about the life of a research project across the school. And so, for example, if colleagues of mine in data science serve a faculty member on a particular project, they can look back later and track the impact of their service by seeing, okay, what are the research outputs that came out of that project? And that interrelates with the research information system and the fact that there are a lot of advances that I'm certainly aware of that many of you in this room and beyond have research information systems that operate in a much more automated way than ours does. We don't do, say, automated harvesting from Crossref or DataCite on publications or data sets. We don't really use ORCID or other persistent identifiers heavily. And so those are really opportunities that we see that we are selling from the bottom up to meet these broader goals. So challenges are because this, ideas are everywhere, prioritizing our time and energy, trying to provide a complex set of services that meet complex needs, but yet seem sort of simple to the user and can interoperate, testing solutions with faculty members that are busy, thinking about how their work operates within school, university, and worldwide research infrastructure, leveraging that worldwide research infrastructure and really trying not to reinvent the wheel. And with so many different complex projects, how to think about if you have a multi-departmental project, who takes the lead on which ones, how do they link together? And then obviously evolving and adapting to continual change that in 2 years from now, we shouldn't still be looking at the same report for thinking about how to advance our services only. So our next steps is we're advancing the research services hub, contributing to use cases in our technology system. One thing we're specifically doing in the library is beginning to design workflows and infrastructure for the library to manage this faculty acquired data, bring and leverage our relationships with other departments to try to explore some of these other systems for tracking publications and research projects, and continually keeping our eye out for new opportunities. So in conclusion, digital transformation has provided us with a valuable lens for scrutinizing, improving, and evolving our research data services. Thank you for your time and staying on, and I wish I could be there with you, but thanks for joining.
Thank you, Katie. And you know the drill already. Time for one more question, or I mean, we can sit here all night if you really like that option.
I see Veronica put her hand up. So can we have a virtual question?
Oh, sorry, no virtual questions. Or can we?
Yeah, you can have, and then we have one from the floor. So we have
I'm sorry.
2 questions coming up.
Okay, thank you very much. Katie, that was a great presentation. I just have, you piqued my interest when you mentioned the personalized services and the scalability around that. And I just from experience know that projects inherently present with a lot of uniqueness, and faculty with other library services always seem to gravitate towards personalized service. You mentioned maybe some tools that could help with the scalability aspect of that. And I wondered if you had any ideas of like what kind of tools might help.
Yes, so I think, you know, maybe far in the future, can we design artificial intelligence possibly, but there are also tools that we're not currently leveraging. So we were exploring a project in our department to provide individual faculty members with an annual report of how they've used our services, so that we sort of raise awareness of, did you know that the service that you had came from the library? And as part of that, we're looking to not only sort of be retrospective, but prospective, and think about how we could be promoting services that they might not know. For example, databases in their field. And some colleagues started to go down the road of, okay, this faculty member is in the finance unit. So individual librarian, to present this report to them, go and look through our financial databases and think what you could recommend to them. And again, that would be wonderful if you have the time, but that's a lot of time. And I said, hey, you know what? We have an online taxonomy for our website that's specific to business. What if we could, as a one-time setting, our metadata librarians could map that taxonomy to our different units, finance, organizational behavior, marketing, and then whenever we have a report, it can automatically pull that in. And so I think part of it is technically, and part of it is just sort of a cultural change that people, you know, sometimes people feel like, oh, if there's not a human service provider speaking with a faculty member, will feel sort of robotic, but I think that there's a lot of ways that we can leverage that better. And then do we have time for one from the floor? Or?
Yeah, there will be the closing question, so to speak.
Hi, Katie. Julie Williamson at Stanford GSB, your colleague there. Hi. So yeah, who should we reach out to if you're leaving Baker now that you're leaving? That's sad to hear. But also just one other thing for our research hub and our services, tracking that, we're using like low code, no code, things like Airtable to track that. So just added that.
Ooh, and I don't know what any of those are. So that's, we should talk.
So this will there be another answer than that the sort of a collaboration will continue in the future?
Yes, yes. And as Tuomas said, I'll be sort of transitioning to something else soonish, and these are sort of valuable for the school and they'll continue. So, but I'm happy to put people in touch.
So everyone in the room of Rachel is still present. One more round of applause to our speakers today, and then you are free to go. Thank you. Enjoy the evening.